Okay, let's look at the next and the last type, which is type 4, the variation type problems. Before we actually do a problem, let's just talk about what does variation mean. There are actually 4 different types of variation problems. One is whenever you have y varies directly with x. When you see the word varies directly here, what I'm going to do is, since we don't have anything means equal, whenever you see the word varies, that's where you can put your equal sign to separate the two sides of your equation. Whenever you're dealing with variation problems, you will always have to have a constant k, and k is a standard constant. So what happens, since it varies directly, it's going to be y, which is equal to k times x. That's one type of variation problem. The second type that you'll have to be aware of is when they talk about y varies inversely. And when you think of the word inversely, you think of something that is inverted. So what do we have is y is equal to k is in the numerator, but x becomes in the denominator. Y, the equals, varies inversely here with k. The next one that you'll run into will be where y varies. Sometimes it's jointly, and when it becomes jointly, then it's with more than one variable, say with both x and z. Well, if that's the case, notice here we have varies jointly, so we have y, k once again is the constant, and I'm just going to multiply those together, which gives me varies jointly. Now, the last type you'll see is where y varies directly. Okay, notice we're talking about directly with x, and notice the word inversely with, say, z. So we've got a kind of a combination one here. What's going to happen is that we're going to end up with y, here's varies, equals, I have a constant k. Now notice it says directly with x, so that means it's going to be straight across, but then and inversely with z. So those are the 4 types that we're going to work, and we're going to work about 2 or 3 problems together, and so that you can make sure, I can make sure that you understand how to set up the variation problems. The first one we will work will actually be, let's look at problem number 22. Hope everybody can read this. Okay, here with problem number 22, it talks about the force needed to stretch a spring a certain distance varies directly. Notice here we're talking about varies directly. Varies directly means that's where my equal sign will go, because that's varies directly. Rather than using x and y, I'm going to use f and d for distance. So here, when I talk about the force, I'm going to use f. I know that it varies directly. K is a constant times, and for distance I'm going to use d. So I have my first setup. I have f, which is equal to k times d. That's going to be your formula that you're going to use. Now, with variation problems, it's always going to be 2 steps. The first step you're going to be doing is you're going to be trying to solve for k. Then once you solve for k, you'll take that answer and use it in step number 2. So what am I going to do for the first one? I know that I have 8 is the force, and k is what I'm looking for, and distance happens to be 3.5. So I'm going to go ahead and do the math, dividing both sides by 3.5, because I'm solving. Remember, we're solving for k. Solving for k. So therefore, when you go through dividing, k is 2.28. Now that you solve for K, we can now do step number 2, and that's this step. I'm going to go back to my original problem. So this is what I have as far as my equation. I know with this particular one here, what we're looking for is the force if I happen to have a distance of 12 inches. Well, I don't know what this is, but I do know what K is, which is the constant, is 2.25, and D stands for distance, which is 12. So even though I may change the number or the distance as far as the inches go for the force, the thing that remains constant is K. So what do I have? Well, I will then just multiply 2.28 times 12, and I would end up with 27.36. So what happens with this is that the force, which you have here, so therefore the force needed is 27.36